chat apps you use every single day, things like WhatsApp or Messenger, we send messages without even thinking about it. They just work. But have you ever wondered what it really takes to build one that can handle millions, even billions of messages a day? Well, we're about to find out.
So how do you build a chat app for, say, 50 million people? The answer is you don't. You start by building one for just 2. And from there, it's this incredible journey of solving one problem after another. We're going to build one right now, from the ground up, piece by piece, and see exactly how engineers tackle these massive challenges of scale.
All right, first things first, we have to get the absolute basics working. Just a simple conversation. How do you get a message from my phone to your phone? It's actually not as direct as you might think. Now, the key thing to get is this. Your phone and my phone, they never talk to each other directly, ever. Instead, when you send a message, your app sends it to a central chat service. That service holds onto it for a split second and then forwards it to the receiver. This middleman server is the heart of the entire operation. Everything we're about to build relies on it. Okay, so the message gets delivered. Great. But how does the receiver's phone know a message has arrived instantly? I mean, you can't have people sitting there hitting a refresh button over and over. That's not a chat app. That's just frustrating. The old school way of doing this was called the pull method. Just imagine your app constantly bugging the server every few seconds. Hey, got anything for me yet? How about now? Anything now? It's just a massive waste of your battery and data. The modern solution, and the one we all use, is the push method. The server keeps an open line of communication to your app and literally pushes the message to you the very instant it gets it. And the technology that makes this magic happen is something called a persistent connection. The best way to think about it is like having a phone line that's always open between your app and the server. It just stays on, waiting. This connection is the real secret sauce behind that real-time, instantaneous feeling we all expect from a chat app. Okay. Things are going great. Our app is a hit. People absolutely love it, which is amazing. But now we have a huge problem. That single server we've been using to handle all these connections, it's on fire, figuratively speaking. It's completely overwhelmed with traffic and it's crashing all the time. So what do we do now? Simple. We scale out. Instead of trying to build one gigantic, super powerful server, we just use lots of normal ones. But then how do you decide which user talks to which server? That's where a load balancer comes in. You put it right at the front door, and it acts like a traffic cop, looking at all the incoming connections and just directing them evenly across our whole fleet of servers. That way, no single one ever gets overloaded. So we fixed the traffic problem, but you know how this goes. We've just created a new one. All of our shiny new servers are now trying to read and write all our chat histories to the same single database. And pretty soon, that database is going to become our new bottleneck and grind the entire system to a halt. The solution here is a really clever technique called sharding. Seriously, this is one of the most critical ideas in scaling big systems. Instead of one giant database that holds everyone's information, we set up several smaller ones. Then we come up with a simple rule, like if your user ID ends in a 1, you go to database 1, if it ends in a 2, you go to database 2, and so on. This spreads the load out perfectly and lets us grow almost infinitely. But it's not just about adding more databases. It's also about choosing the right kind of database. For something like chat history, a traditional database just isn't built for this kind of speed and scale. So instead, big systems use what's called a key value store. It's designed for one thing, getting massive amounts of data in and out at lightning speed. It's no wonder that giants like Facebook Messenger and Discord rely on this exact approach. Okay, look at us. Our app is stable, it's scalable, it's a real robust system. Now it's time to add those little bits of magic, the features that make a chat app feel alive and useful, even when you're not actively using it. First up is presence. You know what I'm talking about. That little green dot next to your friend's name. It seems so simple, right? But behind that dot is an entire dedicated system whose only job is to keep track of one thing: who is connected right this very second. So how in the world does it work? Well, it's actually called a heartbeat. While your app is open, it's constantly sending a tiny little signal to the presence servers that just says, hey, I'm still here, I'm online. And if those servers don't hear that little heartbeat signal for, say, 30 seconds, they just assume you've closed the app or lost connection, and they update your status to offline. It's simple, but it's incredibly effective.
Which, of course, brings us to our very next problem. Let's say your friend's app is closed, the heartbeat is stopped, that persistent connection is gone, their phone is off, sitting in their pocket. How do we tell them they have a new message? Our server can't just reach out and turn their phone on. And this is where the giants, Apple and Google, come into the picture. Our little chat service can't wake a user's phone up, but they can. So when a new message comes in for an offline user, our server packages up the notification and just hands it off to either Apple's push notification service, that's APNs, or Google's Firebase Cloud Messaging. They have special access to the operating system, and they handle that final critical step of waking up the phone and displaying that little alert on the lock screen.
Wow. So we've gone from a simple idea of two people talking all the way to this complex distributed system. Let's take a step back and put all the pieces together to see the final architecture we've built. And here it is, the whole shebang. Right at the front, we've got load balancers directing traffic to our fleet of chat servers. And these servers are stateless, which is a fancy way of saying any server can handle any user. That makes the system super flexible. Then we have those always-on persistent connections for instant messaging. All our chat histories are stored safely in those super-fast, sharded databases. Our present servers are keeping track of who's online with those heartbeats. And finally, the push notification services make sure you never miss a message.
It really is an incredible journey, isn't it? Every single component we've added solved a specific, very real problem of scale. And together, they transform a simple two-person chat into a powerful, resilient communication platform that can connect millions of people all at once. Each piece is absolutely crucial.
Kind of makes you think, right? The next time you fire off a quick message or see that little green dot pop up, you'll know about the immense, elegant architecture that's working like crazy behind the scenes to make it all seem so simple. So, what other simple apps on your phone do you think are actually technological giants in disguise? Thanks for joining me on this one.